We're going to explain how to solve the problem of inhomogeneous shape errors in Python arrays, a common issue when working with NumPy. These errors usually pop up when you try to perform operations on arrays that don't have compatible dimensions. Let's explore how to identify and fix these. 1. Understanding the error. The most frequent error message you'll encounter is something like value. Error. Operands could not be broadcast together with shapes x, y, a, b. This means you're trying to combine arrays with shapes x, y, and a, b, where these shapes aren't compatible for element-wise operations, like addition or multiplication. Broadcasting rules in NumPy allow some shape mismatches, but not all. For example, adding a scalar, a single number, to an array is fine. NumPy automatically expands the scalar to match the array's shape. However, adding two arrays with different dimensions, besides the aforementioned exception of a scalar and an array, generally isn't allowed. 2. Identifying the source. The first step is to carefully examine the shapes of your arrays. Use NumPy's shape attribute. For instance, if you have arrays r1 and r2, use print r1.shape and print r2.shape to display their dimensions. This reveals whether the shapes are compatible. Often, the error stems from a misunderstanding of how your code creates or modifies arrays. Check for unintended reshaping operations, like using reshape to assign incorrectly, or the use of functions that might change the array's shape unexpectedly. 3. Reshaping arrays. NumPy's reshape it function is your friend here. If you need to perform an operation requiring compatible shapes, carefully reshape your arrays using reshape new shape. Make sure the new shape is valid. The total number of elements must remain the same. For example, a 304 array can be reshaped into a 12 array, a one-dimensional array with 12 elements, a 206 array, or a 602 array, but not into a 207 array. Remember that the product of the dimensions must remain consistent. 4. Using array slicing and indexing. Sometimes you don't need to reshape the entire array. Clever use of slicing and indexing might let you select portions of your arrays that are compatible. This approach avoids unnecessary reshaping and improves efficiency. For example, if you only need to perform an operation on a specific row or column, select that part using array slicing. Rsun selects the first row of R. 5. Broadcasting rules. Advanced. Understanding NumPy's broadcasting rules is crucial. Broadcasting allows operations on arrays of different shapes under specific conditions. The key is that the shapes need to be compatible. NumPy will automatically stretch the smaller array to match the larger one if their shapes meet certain rules. Review these rules if you frequently handle arrays with differing shapes. It's a bit more advanced, but understanding broadcasting can help you write more efficient code. 6. Debugging techniques. If the problem persists, print the shapes of your arrays at various stages in your code. This helps pinpoint exactly where the incompatible shapes emerge. Use a debugger, like PDB in Python, to step through your code line by line, examining the array shapes after each operation. In summary, resolving inhomogeneous shape errors in Python arrays involves checking array shapes using .shape, reshaping arrays with reshape when needed, utilizing array slicing for selecting compatible subsets, and mastering broadcasting. Remember, carefully examining your code's array manipulation steps and employing debugging techniques are essential for pinpointing and rectifying these common errors.